Today we are going to study about titration. Titration is a laboratory method of quantitative chemical analysis to determine the concentration of a solution by adding measured sample of a known quantity of another substance. The process is carried out by gradually adding a standard solution. The standard solution is a known concentration of titrant with the help of a burette into a known quantity of analyte, the unknown solution, in a conical flask. The known volume of unknown solution is measured using a pipette. The process is stopped when the end point is reached. This is indicated by the color change of an indicator. Equivalence point is the stage during titration when the added titrant is chemically equivalent to the analyte in the sample. It is also known as stoichiometric point in titration. Now, a procedure called titration is used to determine the amount of substance present in a solution of unknown concentration. There are several different kinds of titration. One of the most common one involves neutralization of an alkali by an acid. Usually we call it as acid-base titration. If we want to determine the concentration of a solution of suppose sodium hydroxide of unknown concentration, we use the following procedure. Use a volumetric pipette to place a given volume of sodium hydroxide of unknown concentration into a conical flask. So at the bottom you can see a conical flask. So here we will put an unknown sodium hydroxide of unknown concentration. Then use a volumetric pipette to place a given volume. So in this conical flask, with the help of a pipette, we will place the given volume of suppose sodium hydroxide solution of unknown concentration. Volume is known, but concentration is unknown. Therefore, we call that as an analyte. Get some of acid of known concentration. For example, it could be hydrochloric acid. For example, the titrant is having a known it is having a known concentration. Yeah, fill a clean burette. So this is a clean burette with the acid, having washed the burette with a little of the acid. So initially you have to wash the burette with the acid, and then we fill it with the acid till the top. Record the initial burette reading. Then we add a few drops of indicator solution to the alkali in the flask. So this conical flask we have at the bottom, we'll add a few drops of indicator solution. It could be, it depends on what solution we are finding out, or we are going through the titration process. It could be phenolphthalein, it could be methyl orange, it could be litmus solution also. So usually a few drops of that indicator is put into the conical flask. Slowly add the acid from the burette. So from the top of the burette, we'll add slowly acid from the burette flask, and then swirling the flask means we have to just shake the flask a little bit all until the indicator changes, and suddenly the end point will come where the indicator will change its color. According to, if it's phenolphthalein, then according to the color it will change colors. Record the final burette reading. Now once we see the end point, we'll record the final burette reading. The final reading minus the initial reading is called the titer. The first titer is normally known as rough value. So that is just, we do it very fast and we get a rough value. But when we are repeating the process, then we have to go very slow at the end point. Otherwise, lot of substance from the burette will enter the conical flask. So we can repeat again until we have at least two titers that have no more than 0.10 centimeter apart. The value should not be until we have a close value of not more than two titers of not more than 0.10 centimeter apart. So take the average of these two titer values. So that's how we can find out the final reading. Now let's do some numericals based on acid-base titration. So things will become much clearer once we do the numerical based on acid-base titration. So the first question is, a 25 centimeter solution of hydrochloric acid is completely neutralized by 18 centimeter of 1.0 mole per decimeter cube of sodium hydroxide. What is the concentration of hydrochloric acid solution? So in this question, what is being asked is, what is the concentration of hydrochloric acid? So the first thing that we have to do over here is write down the equation. So let's write down the equation. HCl plus NaOH will give you salt NaCl plus water. Now, if you look closely at the equation, you'll see that it is already balanced. The coefficient is already uh, 1 for all. So we know we not need to balance it. When we have an equation like this, we can use a formula which is more easy to solve the numerical. So we can use the formula like M acid, that means concentration or molarity of the acid, and V acid, that means volume of the acid, equals to, in between you can write down into, and then we have M base and V volume of the base. So this is a simple formula that we can use. Now according to the numerical, V, that means volume of the acid, equals to how much? 25 centimeter cube. So 25 centimeter cube. We have to convert it into decimeter cube. So we divide by 1000 and we get it as 0. You can write down or 0.025. Now we can have decimeter cube. So we converted it into decimeter cube. Then the molarity. Now remember one thing, the molarity of the acid we have to find out. So we can put a question mark over there. And the molarity unit will be mole per dm cube. So remember that. Now next thing is the molarity of the base equals to how much? If you look at the question, molarity of the base is 1.0. That's, we can write it down, 1.0. Unit is already okay. So mole per dm cube. So the concentration of the base is given there. Then volume of the base. Volume of the base is also given. So it is 18 centimeter cubes. So centimeter cube. So we can convert it into decimeter cube. So again divided by 1000. So we'll get 0.018 dm3. So that's how we have got. Now let's solve it. So we can write down M acid into, that is volume of acid. So we can write down 0.0, value is how much? 0.025 equals to, now M base is 1.0 into volume of the base. What is it? 0. So 0.018. Now M acid, that is concentration, that's what we have to find out, equals to 1.0 into 0.018 divided by 0.025, and we get the concentration of the acid 0.72 mole per dm cube. So this is the final answer, that is what is the concentration of hydrochloric acid. So 0.72 mole is the per 72 mole per decimeter cube is the concentration of acid. So I hope you have understood it. This formula we have to use only when we have stoichiometry. It is all equal. The ratios of acid and base is equal. The problem comes we use another method when the stoichiometry coefficient is different. Now let us do the second example. The second example, if 0.02 decimeter cube solution of barium hydroxide completely neutralizes 61.5 centimeter cube of 0.2 decimeter cube of hydrochloric acid solution, what is the concentration of barium hydroxide? So in this, the first process is to write down the equation. So let's write down the equation. BaOH whole 2 plus HCl will give you barium chloride, that is the salt, BaCl2 plus water. Let's balance it. So there's 2 there, 2 2s are 4. Now this also has to become 2. So now it is balanced. But here we'll see stoichiometric coefficient is 2 for HCl and 1 for barium hydroxide. So we cannot use this equation of M acid molarity of acid into volume of acid equals to molarity of base into volume of base. We cannot use that. So for this we do a little longer process. So let's do it. Let's understand it. So first of all, let's write down the molar ratio. Now, if you look at the molar ratio, barium hydroxide has a molar ratio of 1. So we can write down over here 1, and molar ratio of hydrochloric acid is 2. So there we have written that. Now comes amount of mole. Now, amount of mole we can write down here, amount of mole. So amount of mole of uh, hydrochloric acid and barium hydroxide. So we have already got the value of uh, hydrochloric acid, that is 61.5 centimeter cube, that is the volume of 0.2 decimeter of hydrochloric. So we have the value. Let's use it. So let's make a line over here so that we can do in the half side, we can do the uh, problem. So let's do the first one. So we already know N equals to CV, that is concentration by volume. I hope you remember that. So where N is the moles, C is the concentration, and V is the volume. So the first thing that we have to do is mole of HCl. This is what we have to find out first, HCl. Now let's do that. N equals to C into V. The C is given as 0.2. So 0.2 unit is okay, decimeter cube, so we don't have to convert it into, and the volume is 61.5 centimeter cube. So we have to convert it into uh, decimeter cube. So let's do that, 0.0615. How did we convert it? We converted it by dividing it by 1000. So when we divided 61.5 by 1000, it converts into 0.0615. that is decimeter cube. The unit changes to decimeter cube. So this will be equal to 0.0123 mole of HCl. So remember this. Now we have to find out mole of barium hydroxide. So BaOH whole 2. So already we can fill it up here. We can use a red pen only. So here we have got the mole of hydrochloric acid. So that is 0.0123 mole. Let's write the unit there. So now mole of barium hydroxide. So we'll use the value of hydrochloric moles of hydrochloric acid to find out the moles of barium hydroxide when we use the coefficient. So 0.0123 mole of HCl. This is the mole of HCl into 1 by 2. 1 is the coefficient of barium hydroxide and 2 is the coefficient of hydrochloric acid. 1 by 2. So 1 is, we can write down beside mole of barium hydroxide. So you can write BaOH whole 2 and 2 is mole of HCl. So that is the coefficient of HCl. So when we do that, we get the answer as 0.00615. That is the mole of HCl. So we can write it down there. So sorry, this is the mole of barium hydroxide. So we can write it down there. Let's write it down there. So this is BaOH whole 2. So we can write down 0.00615 mole. So there we have found out the mole of barium hydroxide and we have found the mole of hydrochloric acid. The coefficient of hydrochloric acid was 2 and barium was 1. So we used the mole of HCl and using the coefficient of HCl and barium hydroxide, that is 1 by 2, we found out the mole of barium hydroxide. Now we already know the formula, concentration equals to mole by volume. So here let's put the value down. What's the mole? Mole equals to 0.00615 divided by, what is the volume? Volume is 0.02. So here it's good if we write down the volume also. Volume of barium hydroxide was found to be 0.02, was given in decimeter cube. You'll see over here it's given as 0.02 and volume of hydrochloric acid is 61.5. So we converted it into decimeter cube, so it became 0.0615 decimeter cube. So here concentration of barium hydroxide divided by, sorry, not concentration, mole of barium hydroxide divided by volume. Volume was 0.02. So we got the concentration as 0.31 and the unit will be mole per decimeter cube. This is the final answer. So uh, I hope you have understood here. I hope it is clear to you.